Okay, so let's say we are in the xy plane, and we have an object that starts at, say, x equals 3, so 1, 2, 3, x equals 3, y equals 0, so we're right here. So 3, comma 0 is the initial position of the object. And we give it a velocity in the x direction. So we have a velocity which has an x component, let's say 2 meters per second. And the object is accelerating, and we have it accelerating with an x value of 1 meter per second squared. And we accelerate also in the y direction. So this is just two-dimensional motion. We accelerate it twice. That right. Let's find the position vector as a function of time. So it's just kinematic equations. The velocity vector will be the initial, so we have an x component, which is the initial, which is 2, that's the v naught x, plus ayt, so that is ay is 2 times t, that's the velocity, that's the y component of the velocity, and to that we add the horizontal component, which has, I'm sorry, this is actually 0, right? So this looks like that because the Vy is 0. I don't know why I put the y first. It's a little strange, but the V naught x is here. The V naught y is 0. V naught x is 2 plus ax, which is 1 times t. That gives us the x component. So we normally flip those two, but that's what we have. And then we get the position vector by integrating this. So we integrate in the y, we get t squared over 2, but we just canceled the 2. And then we add the initial position, because the initial velocity is 0. The initial position is y equals 0, so all we have is that. To this one, we integrate, we add the initial position. The initial position is x equals 3, so we have 3 plus v naught x, which is 2 times t, right? We get that from integrating this, and we integrate this, we get t squared over 2 plus t squared over 2 I hat, and that's the position vector as a function of time. Let's make sure that at t equals 0, we are in fact at 3 comma 0. So at t equals 0, sorry, what am I doing here? R of t equals 0. We get this is 0. So we have, in fact, we're going to get 0 comma 3 because the y component comes in first. So we have 0 here plus 0, and there we have the 3 there, 3 I hat. So that's just 3 I hat, the same thing as x equals 3, y equals 0. And so then we can evaluate it at different times. So for example, at a later time, let's say t equals 1, the position vector is 1 j hat plus, this is a half, this is 3, this is 2, plus a half I hat, so that's j hat. And then so we have 5 plus a half, so 5 plus a half, that is equal to 11 halves, so it's 5.5 plus 11 halves I hat. So we are at, let's see, 5, so 3, 4, 5.5. We're somewhere here, and then we're at 1 here. So we've moved from here to there.